Okay, so for example, you want to do a one sample t-test. However, your data does not meet the requirement. So then you'd have to do a non-parametric equivalent. So today I want to teach you how to do a Wilcoxon sign ranks test, but using it to test a claim about a median of a population. So here in this data set, we have this variable here, stores, and you have two sets of stores. So stores either fall in the north branches or the south branches. And here we have pre-promo sales of footballs. So how many footballs some stores sold before a promotion. And here we have post-promo sales. So how many footballs they sold after a promotion. I will explain what this test value means. So even though we're going to do a non-parametric, we must know that a non-parametric also has requirements. So let us briefly look at that. So for the Wilcoxon sign ranks test, in using this, would it be for matched pairs or using it for one sample, the requirements remain the same, because we're basically going to perform a match pairs, even though it's not really match pairs we're doing, right? But the requirements remain the same. So the sample has to be a simple random sample, and we must look at the population of differences and ensure that it has a distribution that's approximately symmetric. Not approximately normally distributed, but approximately symmetric. Alright, say for example, a claim is that the median sale of footballs before the promotion was 230. And we want to use our data here based on the sample we collected to test this claim if the median sale was actually 230. So when we're doing a one sample t-test, we just have to enter the test value. But we don't have that option here because we're doing a Wilcoxon sign ranks test. We're going to create another variable, and in that variable, each one of the values would be the test value. So that is why here all of these are 230. And that is why I'm saying that this will be performed as if you're doing a match pair test, because that's how Wilcoxon sign ranks test works, even though we're really testing a median about a population. Right. So after you enter all of this, normally you have to do it manually, or you could enter some prompt for it to be executed, or or if you want to enter it in like a CSV file before you come to PSPP, because it might be easier to copy and paste. Right. So we have to ensure that one of the things that the requirements for this is that the sample has to be a simple random sample, and we're going to assume that this was a random sample, and the distribution of the differences has to be approximately symmetric. So how we find those differences, we go to transform compute, and we're going to create a new variable, and let's call it diff for differences. So here, because we're looking at pre-promo sales, we're sending that across, and we're going to subtract from that the test values. So we send test value across, we click OK. We go back here to data view, and here is our new variable with all the differences. So now let's look at the distribution of those differences. So we'll go to histogram, from graphs, we go to histogram, and we're going to put diff, send that across, we click OK. We come to our output view, and here we're looking at it, and if you look, it's not exactly symmetric, but if you look at the weight of it, it's basically distributed symmetrically. But this assumption, it doesn't necessarily have to hold strong. It's just that the better the symmetry, the more accurate the p-value is. So nice. So now let's get back, and let us go to analyze, non-parametric, and we're going to do two related samples, because as I said, the Wilcoxon sign ranks test works as if you're testing matched pairs. So that is why we have to use two related samples. But remember, this test that we're doing is really a one sample, testing a claim about a population median. But it's just that the next variable, let me just reset this. Right. So it's just that the next variable we're testing it against is just basically all all of those values will be our test values. So we'll put pre-promo sale in variable 1, and the test value variable, we put it in variable 2, and all the values in this variable is 230. So we're testing all of them against 230. We're going to click Wilcoxon, because that's the test we're doing, and we click OK. What we want to also find, what was the actual median of the pre-promo sales. So we could go to Analyze, Descriptive Statistics. No. We go to, yes, Descriptive Statistics, Frequencies, and we'll select Median. Right, so here we are pre-promo sales here, and then we'll click OK. So we'll come back to our output viewer. So we'll look at the median. The median was 205, and we're testing it against 230, and we see 205 is actually, it's a bit less than 230, but was that difference significant, right? So when we do the test, it gives us a z-value of minus 3.80, which is associated with a p-value in the two tails of less than 0.001, which we know is less than 0.005. So it will tell us that we would reject the null hypothesis, which would have indicated that the median value of the population would have been equal to 230, right? And this p-value tells us we have to reject that, because we could actually see that there's a possibility that is actually less than 230 based on the sample data that was collected. So this is how you test a claim about a median using PSPP, specifically via doing the Wilcoxon sign ranks test.